So in this video we will study about the ideal gas equation and their different variations, how to derivatize this ideal gas equation. So far we have seen that according to Boyle's law, volume is directly proportional or inversely proportional to pressure, or V is equal to 1 over P. And according to Charles' law, volume is directly proportional to temperature, and according to Avogadro law, volume is directly proportional to amount of gas. So we can combine all these three laws together, and we can write like volume is directly proportional to N and T, which is together, and over P, so 1 over 1 P. So we can establish an equation from this combining Boyle's law, Charles' law and Avogadro law. So, or we can also write like V is equal to small n RT. So R is called a constant, gas constant, and it has some value with the different different units, and you need not to remember the R values. It will be given in the exam or test or in the any question, but you have to you find out how to apply this one. So this is the ideal gas equation law, and let's see how so according to ideal gas law we can also write, so you can see this according to ideal gas law, V is equal to small n RT over P, and if you will move this P to the left side, you can also write PV is equal to small n RT, right? So this is the easiest way to memorize this ideal gas law equation. PV is equal to small n RT, where P is a pressure in atmosphere. This is important. Pressure in this equation is always in, you have to use in atmospheric pressure. This is atmosphere. Volume will be in the liter, small n will be the moles, T is temperature, which is in Kelvin. So in any equation, if a temperature is given in the Kelvin or Fahrenheit, you have degree Celsius or in Fahrenheit, you have to convert first into Kelvin, then put it in the equation. And R is called ideal gas constant, which is the value have 0.0821 liter atmosphere per mole Kelvin, and the R value could be different, it can also be in 5 different ways, 1 2 3 4 5, so but using a different units. So in case of liter atmosphere mole Kelvin, this value will be used. Joule over mole Kelvin, this value will be used. Calorie per mole Kelvin, this value will be used. Meter square Pascal per mole Kelvin, when this value will be used, and liter torr over mole and Kelvin, this value will be used. And here this shows this asterisk shows that these are the SI unit, standard units, international standard units. So standard temperature and pressure is defined as 0 degrees Celsius and 1 atmosphere. So if so these two, what is the meaning of standard temperature and pressure, and what that is also called STP, standard temperature and pressure, is defined as 0 degrees Celsius and 1 atmospheric pressure. So this was about the ideal gas equation and how to memorize and what are the name of each letter. So let's see the ideal gas law relationship. So this is ideal gas law, which is PV is equal to small n RT, and from here we can also write like PV is equal to constant at constant amount and temperature. This is a Boyle's law. Or you can also write from here that volume is directly proportional to temperature, or V over T. This is a Charles law. at constant. If we keep constant amount and pressure, then these two will also be constant. And this is according to Avogadro law, that volume is directly proportional to amount of a gas, which is V over N, is called constant at constant pressure and temperature. So if any two of them, two variation we can make the constant, then we can derive the Boyle's law, Charles law and Avogadro law, because ideal gas is a combination of these three laws. So this was the application of gas law. And if we have to compare the two conditions in the gases law, so we can also write like PV is equal to small P1 V1 upon T1 is equal to P1 P2 V2 upon T2, where moles of gases kept constant. So if amount of a gas is constant, R will always remain constant, then we can also write, so for an example, like a PV is equal to small n RT, and if the amount of is constant, R is already constant, so we can make this also as a P1 PV upon T is equal to constant. In that case, P1 V1 over T1 is equal to P2 V2 over T2 when we are compare the two different conditions using gases law. And this is another application of the gas law. We can also calculate the density of a gas. So let's see how we can calculate the density, and just to modify the simple ideal gas equation, like a PV is equal to small nRT, and we know that small n is the amount, and if we move this volume on this side, so n over V we can also write, or amount on this side and P on this side. So n over V is amount, which is mass in the mole, and so small n is equal to mole, and V is the volume, and P is pressure, and R T. So since small n is equal to mass over molar mass or molecular mass, so we can replace the W over M here in this equation. We can also write like W over M, which is a small n, number of mole, and then once we will separate this W upon V, mass over volume is density is equal to mass over volume. So we can also calculate the density, which is equal to M molar mass, P is pressure, R is gas constant, and T is temperature. So this is the equation for the density. So you need not to memorize that equation. You can also simply derivatize whatever you want, and that will be the easiest way. I will say that if you know that volume is mass over molar mass, and then just replace the volume and this number of moles into this equation, and then convert mass over volume is the density. So this is the way we can find out the density of a gas. And this slide is again same thing, that once you will write that D is equal to MP RT. So here these values are assigned, like what is D for density, M is molar mass, P is pressure in atmosphere, R is a gas constant, and T is temperature in Kelvin. So these were the examples about the how to make this ideal gas equation, and what are the information we can get from ideal gas equation. And ideal gas equation is made from the Boyle's law, Charles law, and Avogadro law, and we can get the density of a gas also through ideal gas equation. And in next video we will see some examples, practice question about the ideal gas equations and how to apply this in the practical questions.